going to prove the mean value theorem for integrals, which states if f is continuous on AB, then there's a number c in AB such that this is true. So what we're going to do is we're going to define, so let me actually write that. Let me write proof, and we are going to define big F of x to equal the integral from a to x of f for t dt. Now, the first thing I would note is that f prime of t is equal to f prime of x is equal to f of x, little f. Now, the mean value theorem says that if you compute, so by the mean value theorem, not for integrals, we know that f of b minus f of a is equal to, well, let me divide. By b minus a is equal to f prime of c for some c in AB. Okay, we know that's true. We know that that's true. Now, note that so we have this. That is, rewriting this equation, f prime of c is equal, times b minus a times b minus a is equal to f of b minus f of a. Now, we know that f of x is the integral from our a to x of f for t dt. So, the question is, what's that? Well, f of b is, well, let's do the whole thing. F of b minus f of a. So basically, whatever is in here, you write this down, and whatever is in here, you put up there. Okay, this is equal to the integral from a, this is the integral from a to b of f for t dt minus f for a. Well, that's the integral from a to a of f for t dt. But that's 0. So what we have is that f for b minus f for a is equal to the integral from a to b of f for t dt. Okay. Now, we know by the mean value theorem that this, which is that, equals f prime of c times b minus a. That is, just not copying down this part, we concluded that the integral from a to b of f for t dt now, I hope I wrote it somewhere, that f prime of x, big F prime of x, is little f of x. So this here is little f prime of c times b minus a. And that's what we set out to prove. Sometimes, and this is for c in AB. And sometimes they divide both sides by b minus a. So we get f prime of c is 1 over b minus a times the integral of, so I do have one typo. Like I said, big F prime of c is just f for c. F equals f prime. So it should be no prime there. From a to b of f for t dt. And I can also say, since t is a dominant variable, that it's f of x dx. Now, we proved it. The proof is done. This is for c in ab. Okay. Now, what exactly is this saying? Actually, the other version is saying it better. That is, f for c times b minus a is equal to this integral. Okay, what it's saying is the following. So here's a, here's b. I am going to draw f of x, and the area from a to b is whatever is in blue here. Now, this here is the base, and that's some f for c. Okay, that's f for c. So what we're saying is, if we compute this area, I mean, I guess it should have been a little bit lower. Actually, let's make it a little bit lower. Suppose f for c is right there. Okay? I didn't mean for it to intersect at b either. So now, if you calculate this area, well, you're gonna get this area, which you should be getting. You're also gonna get this area. So that seems like everything, but you're not getting that area. And I guess that this area and that area are equal. They cancel out. So basically, one would call this f for c, the average height. You can call this the average height of f of x from a to b. It's the average height. So if somebody gives you a function, here is some function, and they ask you, what is the average height from a to b? What you should do is compute this. Compute their area under the curve from a to b, and then multiply, and that will give you a real number, and then multiply by 1 over b minus a, or divide by b minus a, and you will have the average height. And it'll be guaranteed that for some c in AB, that f for c will actually equal this number. I know we just proved it. See you next time.